In this video, I am going to talk about what's called the empirical rule, and for data that have distribution that is bell-shaped. And the following is the data of SAT scores for 2023 from the College Board. And so in 2023, there were 1,913,742 students who took the SAT test. And then the College Board also calculated the population mean is 1,028, and then they also calculated the population standard deviation is 221. So this is the relative frequency histogram for the SAT scores. And so what I'm going to do now is I'm going to take this histogram right here, and then I'm going to rotate it 90 degrees. And then it looks like this. So in this case, we say that the relative frequency histogram right here of SAT score is bell-shaped, or approximately bell-shaped, because it looks like a bell right here. And so what I did here was I used a graphing calculator and then draw a curve. This is called a bell curve with the population mean of 1,028 and standard deviation of 212. And then here we can see that the bell curve is superimposed on the relative frequency histogram. And so in this case, we say that SAT scores have a distribution that is approximately bell-shaped, with population mean of 1,028 and population standard deviation of 221. And so when a set of data have a distribution that is approximately bell-shaped, and then we can use what's called the empirical rule. And the empirical rule says that the approximately, so the middle here is the mean. In this case, it's 1,028. And the empirical rule says that approximately 68% of the SAT scores are between mean minus 1 standard deviation and mean plus 1 standard deviation. And then the empirical rule also says that approximately 95% of the SAT scores for the year 2023 will be between the population mean minus 2 standard deviation and population mean plus 2 standard deviation. And then almost all of the data, all of the SAT scores, or 99.7%, will lie between the mean minus 3 standard deviation and the mean plus 3 standard deviation. And here's how we calculate it. So the empirical rule says that 68% of all SAT scores in 2023 are between mu minus sigma and mu plus sigma. In this case, mu is the population mean, which is 1,028. Sigma is the population standard deviation, which is 221. 1,028 minus 221 is 807. And then 1,028 plus 221 is 1,249. So approximately 68% of all SAT scores are between 807 and 1,249. And so graphically, this is how we would represent it. So to generate this bell curve right here, we can use a graphing calculator, and then here right in the middle is the mean, which is so right here this is 1028, and then if we go one standard deviation to the right, we get 1249, and then if we subtract one standard deviation, then we get 807. And then the shaded area here would be 68%. The total area between this is called the x-axis. So this is the bell curve right here. So the area that's between the bell curve and the x-axis here is always going to be 1. And so the 1 or 100%. And so the shaded area here is 68%. And then the empirical rule also says that 95% of all SAT scores in 2023 will be between mu minus 2 standard deviation and mu plus 2 standard deviation. Once again, mu, the population mean, is 1028 minus 2 times the standard deviation, which is 221, and then similar here. So simplify all of this, we get 586, and then simplify all of this, we get 1040. So the empirical rule says that approximately 95% of all SAT scores are between 586 and 1470. And again, graphically, this is how we would represent it. And so once again, the area between the bell curve right here and this is the x-axis is 1 or 100%. The shaded area here is 95%. And then right in the middle, this value right here is 1028. And then 1028 plus 2 standard deviation is 1407. And then 1028 minus 2 standard deviation is 586. The empirical rule also says that 99.7% of all SAT scores will lie between mu minus 3 sigma and mu plus 3 sigma. So in this case, the population mean once again is 1028 minus 3 times the standard deviation, and then 1028 plus 3 times the standard deviation. And then simplify this part, we'll get 365, and then here we'll get 1691. Another type of scores that also have a distribution that is approximately bell-shaped are the IQ scores. And then IQ scores have population mean of 100 and population standard deviation of 15. And so by the empirical rule, 68% of all IQ scores are between mu minus sigma and mu plus sigma. So we have 100 minus 15 and 100 plus 15, or 85 and 115. So 68% of all IQ scores are between 85 and 115. And graphically, this is how we would represent it. So we use a graphing calculator to generate this bell curve right here with mean of 100 and standard deviation of 15. And then the shaded area here would be 68%. And then by the empirical rule, 95% of all IQ scores approximately will lie between mu minus 2 sigma and mu plus 2 sigma. So be 100 minus 2 times 15, 100 plus 2 times 15, which is 70 and 130. So approximately 95% of all IQ scores are between 70 and 130. And then graphically, once again, This is how we represent it. So here's the mean with is 100, and then if we go 2 standard deviation to the right, we'll be at 130, and then 2 standard deviation to the left, we're at 70. And then the once again, this is the x-axis, and then this is the graph. The bell curve corresponding to a mean of 100 and a standard deviation of 15. The total area under the curve is 1 or 100%. And so here the shaded area is 95%. And then the empirical rule also says that approximately 99.7% of all IQ scores are between mu minus 3 sigma and mu plus 3 sigma. So we have 100 minus 3 times 15, and then 100 plus 3 times 15. This part will be 55, and then this part will be 145. So approximately 99.7% of all IQ scores are between 55 and 145. And then graphically, this is how we shade it. So the shaded area here is 99.7, and then right in the middle right here, this is 100, and then go 3 standard deviation to the right, then we're at 145, and then go 3 standard deviation to the left, we're at 55. So that's how we apply the empirical rule. And this is the end of it.